This lesson is jam-packed with learning targets. One is that you can explain the overall job of the circulatory system, and two is that you can explain how blood flows, the direction of blood flow through the body. Three, you can explain the difference between these three structures, veins, arteries, and capillaries, which means you know what they do and what they are, how are they different from each other. And that you know what blood pressure measures, probably had that taken before. And then lastly, that you can describe structure and function of your heart. Let's begin. Your circulatory system has two main jobs. One is that it transports oxygen and nutrients around the body. And the key word here is transports. It's your transportation system in your body. It moves things around. And secondly, it's helping you get rid of waste like carbon dioxide and other waste that your body gives off, something called urea, which is the component of urine. Ultimately, that travels to your kidneys and it gets filtered out, and then you pass out of your body when you go to the bathroom. I thought we'd start by looking at this super cool image, two images from the Bodies exhibit, which is a traveling exhibit. I don't know where it is in the country at the moment. It's been in Seattle a couple times. Basically, they take human bodies and they inject them with plastic, latex, so that then the rest of the tissues, whatever part they want to look at, in this case the circulatory system, and then they dissolve away the rest of the tissue. So you're just left with the parts of the circulatory system. So here you might be able to see this is someone's hand, all the blood vessels in a hand. And over here we have the heart. This is the upper part of, or lower part of your windpipe. And then these are your lungs. And you can see all the blood vessels that are there embedded in your lungs. So let's get into the parts of the circulatory system. We'll start with the blood vessels. There's three types. And we'll start with arteries. So arteries move blood away from the heart. That's actually how I remember what they do, because they start with A, and the word away starts with A. So arteries carry blood away from the heart. They have very thick and elastic walls. If you look at a cross-section, one of these from the inside out, you can see there's lots of layers here. We have connective tissue and smooth muscle tissue, and so they're very elastic and stretchy. And arteries tend to carry oxygen-rich blood, so we always represent arteries with the color red. Red is for oxygen-rich blood. Secondly, we have veins. Veins go the opposite direction. They move blood toward the heart. And to help with that, because generally they're fighting gravity on this, they have valves. So again, vein starts with V, valve starts with V. So valves are like little one-way doors. So here you can see one in this vein. And when the blood pushes through that one-way door, it can't go backwards. That little one-way door shuts, so that prevents blood from going in the opposite direction. And generally at this time, veins are carrying oxygen-poor blood, which means they've dropped off the majority of the oxygen at cells and have now picked up waste, carbon dioxide and other waste, and are carrying that back to the heart and to the lung. Here's another picture of those one-way valves. So again, the blood pushes through, the valves open, and then those valves shut so that the blood can't go backwards. The third type of blood vessel is capillaries, and capillaries are the teeny tiniest blood vessels. They're microscopic. Maybe you've been able to see these, like if your eyes are really bloodshot, like from being too tired. Their walls are only one cell thick, which is important because this is where the gas exchange is happening from the cells to the blood and back and forth. So they can't be very thick because otherwise materials can't pass in and out of them. So they are what connect arteries to veins, and it's where that gas exchange, nutrient exchange, waste exchange is happening. So these are located all over your body. Here's another picture that kind of shows the relationship between all three. Capillaries are all of these. They connect arteries to veins. Here's another way to look at it. This one's nice too because it shows how the gas exchange is happening right here. The blood is moving from red, oxygen-rich blood, to oxygen-poor blood. And our blood is never blue, but we use the color to represent oxygen-poor blood. So this is a better picture to show the color exchange. So again, arteries are carrying that oxygen-rich blood Veins are carrying oxygen-poor blood. And it's just darker in color. There's actually a chemical reaction that makes your blood bright red when it's carrying oxygen. So as that oxygen leaves and it's going through the capillaries and into the cells, it becomes darker red. So it's never blue, just more of like a dark purple or dark red. Here's another picture that shows kind of the main arteries and veins in the body. Again, the color is there representing oxygen-rich and oxygen-poor. And your blood takes 3 pathways through the body. So one of those pathways carries it just to the lungs. So this is like a loop that takes blood from the heart to the lungs and back to the heart. And we call that pulmonary circulation. Every time you see this word pulmonary, it has to do with the lungs. Okay? The second route blood is taking is that it's just to the heart tissue itself. There's a network of blood vessels that feed oxygen and nutrients and pull away the waste from the heart tissue itself, the cardiac muscle, because we know we don't want that to die off. If it dies off, then that's a problem, because then that can be what causes or triggers a heart attack. So that's called coronary circulation. Every time you see this word coronary, it's dealing with something about the heart. And then finally, of course, you need blood in all the other parts of your body, not your heart and lungs. So that is called systemic. So to your brain, to your arm, to your stomach, to your legs, that would be considered systemic circulation.
The blood travels through the body in a continuous system of tubes called blood vessels. This system is so huge that if one person's blood vessels were stretched out straight, they would reach almost halfway to the moon. There are 3 types of blood vessels: arteries, veins, and capillaries. Arteries are large blood vessels that carry the blood away from the heart. Arteries divide into smaller and smaller vessels until they are so small they can only be seen through a microscope. These vessels are called capillaries. There are so many of these vessels that most living cells of the body are close to capillaries. The capillaries rejoin to form veins, which are the blood vessels that return blood to the heart. In this diagram, the arteries are shown in red to represent oxygen-rich blood, and the veins are shown in blue to show oxygen-poor blood. The largest artery is called the aorta. It is about 1 inch in diameter and receives the push of blood from the left ventricle. There is quite a bit of pressure behind this push, so arteries are designed to be flexible. They expand and then move back to their original sizes and shapes, which provides even more push. Some of the blood is directed immediately back to the heart to provide it with nutrients and oxygen. The heart cells need to be continuously supplied with nourishment. Through coronary circulation, blood is supplied to the blood vessels of the heart. If the cells of the heart aren't supplied with oxygen or nutrients, a heart attack can result. Heart attacks are a leading cause of death in the United States. They can be caused by blood clots that block blood vessels, or buildup of cholesterol, fibrin, or other material in blood vessels can narrow the path or openings in the vessels. Remember that one of the critical jobs of the circulatory system is to transport oxygen and food to all living cells, and then to collect waste products, such as carbon dioxide. The exchange of gases takes place in the capillaries. These vessels are so small that they are only 1 cell thick. This makes the transfer of materials possible. There are so many capillaries that every living cell in the body is within their reach. The capillaries are so thin that red blood cells have to squeeze through them 1 cell at a time. After blood cells have delivered nourishment and picked up waste, they move into larger vessels called veins. Veins return blood to the heart. They are structured similarly to arteries, with 3 layers of muscle and connective tissue. Veins must overcome the pull of gravity to get the blood back to the heart. The push from the heart that propels the blood through the arteries is no longer much of a factor. There are 2 things that help to move the blood through the veins. The larger veins have one-way valves that prevent the blood from flowing backwards. The veins are located between skeletal muscles, and when the muscles contract, they force the blood forward through the veins and towards the heart. If a person stands still for a while, the blood will collect in his or her feet and ankles. If this continues and the brain doesn't get enough blood, a person might faint. When people walk, jog, or run, the muscles in the legs contract and relax, which causes the veins to be squeezed and released. This causes the blood to move along the vein towards the heart.
Of course I have a pulse. Try again. Dear Tim and Moby, how does blood move through your body? From Josh. Blood circulates through your body in a network of blood vessels. This network is miles and miles long. Your heart, blood, and blood vessels make up your cardiovascular system, also known as your circulatory system. The cardiovascular system is responsible for a cycle that moves blood from the heart to every part of your body and back again. At the center of your cardiovascular system is your heart. The heart is a muscle that pumps blood through your body, and it handles 3 types of circulation. Your heart has its very own network of blood vessels that brings nutrients in and removes waste. This is called coronary circulation, the flow of blood within the heart itself. Pulmonary circulation is the flow of blood through the heart to the lungs. In the lungs, blood drops off carbon dioxide for you to breathe out. Then it picks up the oxygen that comes into the lungs when you breathe in. That oxygen-rich blood heads back to your heart, which brings us to systemic circulation. Systemic circulation brings oxygen to all the cells that need it and removes their waste products. Blood cycles through your body by moving from your heart to your arteries. It goes into smaller blood vessels called capillaries, and then into veins, then back to your heart. Blood leaves your heart through a big artery called the aorta. Blood drops off its cargo of nutrients and oxygen, providing your cells with the fuels they need to do their jobs. Then it picks up carbon dioxide and other waste products, taking them away for disposal. Solid waste is dropped off at the kidneys, and carbon dioxide is exchanged in the lungs for a fresh supply of oxygen. And then it's back around again, all day, all night, including weekends and holidays, for the rest of your life. Do we have to do this now? Huh? You're alive. You're alive. Dad. Dad, Moby's alive. He's not a robot after all.
Now, I know you've had your blood pressure taken before when you've been to the doctor, so let's talk about what that means or what they're actually measuring. So when they're measuring blood pressure, they're actually measuring the force that blood is pushing back on your blood vessels. Usually they measure it in an artery because it's higher and easier to measure there. So they basically put this tool on your arm, it's called a sphygmometer, and it has this little pressure gauge. So they pump up pressure inside the pump so that they are able to measure how much there is of pushback from your veins or from your arteries. If they don't pump it up, then there is no way to measure that pushback. So they generally get 2 numbers from that reading, for instance 112/60, and the reason you get 2 numbers is because there's 2 stages of your heartbeat, the lub and the dub, if you remember from Bill Nye. So the first number is blood pushing out of the heart, so that's the big number because that's the strong push. And the second number is when the heart is refilling, because it can't just continually push blood out of the heart unless it also refills. So You may have also measured what's called your pulse, which is just a wave of blood pressure up, usually near someplace near the outside of your skin where you can feel it with your fingers. Hopefully you've done that in fitness class. Here's a picture that shows good and not so good blood pressures. You may have heard this word hypertension. Hypertension is the name for high blood pressure. So that's something you want to avoid because that just means that your heart is working harder than it should, and that can cause problems in your body.
Ow, that's too tight. You relax. Dear Tim and Moby, what is high blood pressure? From Eileen. Well, your heart contracts and relaxes when it pumps blood through your body. This forces blood through your arteries. Blood pressure is the force exerted by the blood on the walls of these blood vessels. Pressure waves are started by the heart's pumping action. You can feel them at the wrists and at other points where arteries lie near the surface of the body. Yeah, these are places where you can take your pulse. Blood pressure is highest during the first part of the heartbeat when the heart contracts and pushes blood into the arteries. This is called systolic blood pressure. On the second half of the heartbeat, the heart relaxes and fills with blood. The pressure here is at its lowest, and this is called diastolic blood pressure. Blood pressure is read as systolic over diastolic, like 120 over 80. Normal blood pressure levels are between 100 and 139 for systolic, and 80 and 89 for diastolic. Over the course of a day, your blood pressure rises and falls. It's usually lowest when you're resting. Types of stress like exercise, fear, excitement, or sudden cold will all raise your blood pressure temporarily. Anytime your heart has to work harder to pump blood faster, your blood pressure rises. Well, having high blood pressure all the time is actually a condition called hypertension. When the arteries narrow or constrict, it takes more effort to pump blood through. Artery constriction and hypertension can happen for several reasons. Getting older, being overweight, or smoking. And high blood pressure can also be hereditary. Hypertension can lead to serious problems like heart disease, strokes, and kidney failure. But doctors know plenty of ways to treat hypertension, like getting regular exercise, low sodium or low fat diets, reducing stress, and medication. It's a good idea to keep track of your blood pressure no matter how old you are. So what is it? What's my blood pressure? What? That's impossible. It's 115 over 80, not 80 over 115. Hey, maybe we should check your blood pressure. Ow! Well, that's gonna leave a mark. Dear Tim and Moby, what makes a bruise so colorful? Thanks, Webster. A bruise, like the one that's forming on my arm right now, is a blue or purplish mark that you can see on your skin. It's also called a contusion. A bruise means that blood vessels have broken deep down under your skin. The purple-blue color is caused by red blood cells leaking out of those broken blood vessels. Oh, don't worry, it's usually not very much blood at all. A cut or a scrape is usually caused by a sharp object that breaks the skin, but a bruise where the skin isn't broken is usually caused by deep pressure or a blow from a blunt object. The life cycle of a bruise goes something like this. Let's say something hits you in the arm. You'll probably have a little bump, and the area will look red or purplish and feel pretty tender. Yeah, that hurts. The area may also swell from blood collecting under the tissue. After a couple of days, the mark will start to look kind of black and blue. The changes in color are caused by your body metabolizing or breaking down the red blood cells released from broken capillaries. It shows that your body is healing itself. After 5 to 10 days, the bruise may start to look greenish and yellow. It'll turn brown after 10 to 14 days, then just kind of fade out. Well, bruises go away faster or slower depending on how quickly your body heals. There's really not much you can do for a bruise, although putting on a cold compress or anything cold and damp can help the swelling go down. Yeah, thanks. A few factors can affect how easily you bruise. For one thing, bruising sometimes runs in families. And women usually bruise more easily than men. Older adults bruise pretty easily because there's less fat under their skin to offer protection. Certain medical conditions can also cause frequent bruising, like taking medicines that thin your blood, diseases like hemophilia, or a diet lacking vitamin C and K. But most bruises are nothing to worry about. Hey, why don't we play something a little less hazardous? Yep.
Okay, that brings us to the heart itself. And overall, your heart's function is this: to pump blood through the body. Your blood does not move by itself. The heart is what pushes it. Okay, and there's different phases of your heartbeat. When these lower chambers fill up, that's basically the lub, the strong push. And then when these chambers up here fill up, that's the dub. So there's two phases. And you may have noticed here on this diagram too that there is actually kind of two halves of your heart. There's the right half and the left half. So let's talk more about structure. Okay, so first of all, when we are looking at the heart and labeling the heart, we have to understand that we have to imagine this heart as being in our body. So if you took your paper and hold it up to your chest, like I'm doing right here, this is my right side and this is my left side. And all heart diagrams are always labeled that way. So just keep that in mind as we're going through the next part. Okay, so anytime you see text come into this document, I want you to write that down. I didn't underline it just because I thought it was too messy. And then once everything's underlined and written, then we're going to be using some colored pencils to shade things in. Okay, so first of all, you may have noticed that the heart has 4 chambers. And going off of what we just said about right and left, we have 2 upper chambers. And those upper chambers are called atriums. Okay? So this is the right atrium here and the left atrium over here. The 2 lower chambers are called ventricles. So here's the right ventricle, and this one next to it is the left ventricle. Feel free to pause at any time if you need more time to write. All right, as we get going here, we have some other vessels coming in and out of the heart. So we're going to label those too. This one, this big one at the top, is actually your largest artery in your body. It's called the aorta, and it stretches up here and it breaks off into other smaller vessels. It also, one of these goes down behind the heart, so this is actually the aorta down here as well. Then you've got this other big vessel here, and that is called the pulmonary artery, and it splits one to the side and one to the side because there's 2 lungs, and you should know from earlier in the lesson that pulmonary refers to the lungs. So the pulmonary arteries take blood from the heart and to the lungs, and then it has to come back to the heart to get pumped to the rest of the body. So right here are the 2 pulmonary veins. So again, think back to the language you just learned earlier in the lesson. Arteries move blood away from the heart. Veins are moving blood toward the heart. So that's why they are named the way that they are. Okay, now let's talk about how it functions. First of all, we have a left and a right lung, okay? And we learned a little bit about lungs in the last unit with respiration. There's more to say about that, but basically, this is the overall function. Blood is dropping off carbon dioxide and picking up oxygen, right? So write that over here. And this is primarily happening in capillaries that are surrounding the alveoli inside the lungs. So we'll get a little bit more into lung structure and function in a future lesson, but you should know this word, capillaries, right? That's where gas exchange is happening. The alveoli are these little sacs inside the lungs that have capillaries surrounding them. So that's what's happening there. Now, if we were to represent this with colors, and I want you to shade in your heart with these colors, we're going to start with blue. We're going to imagine that blood has been out in the body, and it's coming back to the heart to be cleaned, basically, to drop off carbon dioxide and pick up oxygen. So I'm going to erase what I've written here so far, just so that it's not confusing. And basically, I'm going to use my blue colored pencil and draw in some arrows here, okay? So this dirty oxygen-poor blood is coming into the right atrium. That's the first place it enters. It's going to go through this valve and then to the right ventricle, okay? The right ventricle is going to squeeze really hard and push that blood into the pulmonary arteries, where it is going to go to the lungs. So I'll just draw arrows here. It goes both directions to each lung. Okay, and over here, I'm just going to color in kind of halfway, right? Because it's going to go all over in the lungs, but this is where it's going to pick up oxygen. So this is where I have to switch colors now, because we use red to represent oxygen-rich blood. So now I've got rich, oxygen-rich blood that needs to go back to the heart so it can be delivered to the rest of the body. So now I don't have the right vessel connected over here, but there is a pulmonary artery over here that's represented on this side. It's going to re-enter the heart here at the left atrium from those two vessels. It's going to go down to the left ventricle, so here, and then it's going to go up through the aorta, and the aorta is going to split and carry it to the other parts of the body. Okay, so if you look at the heart diagram, your heart is really two pumps, a left and a right pump. And one pump, the right pump over here, carries oxygen poor blood, or pumps oxygen poor blood from the heart to the lung. And the other half of the pump, the left side, pumps blood from the heart out to the rest of the body.
So, I hear you have a letter for me. Oh, a love letter. And it's not even Valentine's Day. Of course it's a Valentine. Look at the envelope. Oh. Dear Tim and Moby, sometimes when I'm playing hockey, my heart beats so loud I can hear it. What's that all about? From Lana. Right. Hearts, because the letter was about the heart. All right. This is an important question, so I want to be sure we understand a few things about the heart. The heart is a powerful muscle in your chest, about the size of your fist. The heart muscle is different from other muscles. It never gets tired, and it pumps blood through your body so that oxygen and nutrients can get to the organs and tissue that need them, and so that cell waste products can be removed. The heart is made up of two pumps, one on the left side and one on the right. Each of the pumps is made of an atrium and a ventricle. The atria bring blood back into the heart and pass it to the ventricles, which pump the blood back out. This pumping cycle produces your heartbeat. Here's how it works. When your brain sends a signal for the heart to beat, the right atrium fills with used blood that has been through the body and needs to go to the lungs for more oxygen. The left atrium fills with fresh blood from the lungs that is ready to go back through the body. The atria squeeze blood to the ventricles below. When all the blood is in a ventricle, the valve between the ventricle and atrium closes, and the ventricle pushes the blood out of the heart. The right ventricle pumps old blood to the lungs. The left ventricle pumps fresh blood into your body so it can circulate. It takes about 1 minute for blood to circulate through your entire body and back into the heart to be pumped out again. So, now we know how your heart beats. The process of pumping blood is one that your body does automatically over and over again, no matter what you're doing. Right. Lana asked about feeling her heartbeat during sports. Your heart rate increases when you run and play, and even when you're nervous. Think about it. When your body is working hard, the muscles tire out quicker. Your heart has to beat faster to get oxygen through your body so that you can keep going. The faster and harder your heart is beating, the louder it sounds. Well, I I hope that answers your question, Lana. Another one?